All right, so here's our picture from number 5, or the diagram for it. So we know that this thing goes through the point 0, 3 up here, and if the ball is just rolling along the horizontal axis, that means that I have some coordinate over here. I'm not sure exactly where it's going to be, but we're going to use h, comma 3, and it's 3 because it's going to have the same height. We just don't know how far it's going over, so we're using h and k just because those are the variables we use for the center of a circle, for the coordinates that is. So remember, the general equation for the equation of a circle here is this. Okay, and so according to the information we have in the graph, diagram on the right there, the third circle there, I can put in x minus h because it's the coordinate for h, plus, and then y minus, and then the k value is 3 equals to, and the radius is still 3 because that's what it was originally. So we know that this thing also goes through the point 10, 1. Now I want to find what p is over here, and that's great, but we need more information. I need the actual equation circle, so I need to find what x is going to be. So what I'm going to do here is I'm going to take the point 10, 1, and I'm going to plug it in for x and y. 10 minus h, quantity squared, plus 1 minus 3, that quantity squared, equals to 9. So I have 10 minus h squared plus, and then negative 2 squared is 4. And I can subtract 4 from both sides. And when I do that, I end up with equal to 5. Now I could expand out the left-hand side either using FOIL or distributive property, however you want to think about that, but I could also just take the square root of both sides. Makes things easier. Okay, so I have 10 minus h equals to plus or minus square root of 5. And so as I solve for h, I end up with 10 plus or minus square root of 5. Okay, which is great, but remember, that's not what the question was asking for. They were asking for us to solve for the value of p. Now if I look back at the diagram, the relationship between h and p is that they are 3 units away from each other because the center of the circle relative to a point on the circle, and the radius is 3 units, so I get that. Now that means that the coordinates of p are going to be p comma 3 is going to be the same thing as h plus 3 because I'm adding that 3 to the radius, comma 3. So the thing that's a little bit tricky about this question is that we have 2 values for h. One of them is for the picture we have here. The other one is a circle that looks something approximately like this, where it goes out there, passing through that point, and we just don't know what it's going to be. So in order to actually help us out here, what I'm going to do is I'm going to plug in 10 plus square root of 5 plus 3, comma 3. And then I'm also going to do over here 10 minus square root of 5 plus 3, comma 3. And so it's the same thing as 13 plus square root of 5, comma 3. And then we have over here 13 minus square root of 5, comma 3. Okay. So when we look at this thing here, we end up with 2 different values for this. One of them, the one on the left there, if I type in my calculator and get decimal approximation, comes out to be approximately 15.24, which actually that's not right. 15.24. So when I plug that in, I get this, and it's approximately 15.24, comma 3. It doesn't make sense for the diagram. If the center is going to be to the left of 10, that doesn't really help it. Or sorry, the point is going to be just to the right of 10. Doesn't make sense. But if I type in this one, the 13 minus square root of 5, comma 3, I end up with approximately 12 or 10.76. I get 10.76 approximately. That makes more sense for what we're trying to do. But keep in mind, if they're asking for the value of p and it says it doesn't say anything about rounding, I would stick with this as my answer right there. Okay, it's not rounded at all. It's good to go. Okay. Now it's a tough problem. Take some time that we've gone through it. See if you can redo the problem. Maybe change the problem up slightly. See if you can work backwards from it. And as always, I'm happy to help with that stuff.